Good day everyone, and welcome to where we are putting together solutions to those additional mathematics questions that students are struggling with. In this video, we will be looking at section 1 of the syllabus, Algebra, Sequences and Series. We'll be looking at the past paper solutions from May 2017 until May 2022. Don't forget to like the video and add any comments down below so we can create other videos to help you in whatever areas that you're struggling with. Have a look at the description down below where we have outlined a guide for you to cover the entire CSEC Add Maths syllabus. Let's look at the 4 major topics in CSEC Additional Mathematics. And in this video, we'll be looking at section 1, Algebra, Sequences and Series. This section comes for 15 multiple choice questions out of 45 in paper 1. That's 1/3 of the paper. And for the first 2 questions with 15 marks each, which is 30 marks out of the total of 100 in paper 2. We're following the new syllabus which began in 2021. And this varied slightly from the older syllabus in 2012. Section 1 has been subdivided into 5 parts, which are algebra, can be subdivided into the 4 operations of algebraic expressions, adding, subtracting, multiplying, dividing them, factorizing polynomials up to the 4th degree, up to x to the 4th, and of course then that will carry us to remainder theorem, factor theorem, and then we can find unknown coefficients. So that's a subset of the first topic, algebra. And for the second, part B, is quadratics. In quadratics, students are expected to be able to complete the square, and there are 3 different ways at least that we can try. The expansion form, memorizing the formulae, or using algebra tiles. And this will lead us to getting the maximum or minimum of the quadratic graphs and the intercepts on both axes, the x and y axes, so that we are able to sketch the quadratic graph. In making such a sketch, the nature of the roots are required, so we need to know the discriminant. That way, we will be able to identify whether there are 2 roots, 1 or none at all. Also, in quadratics, we need to be able to solve reducible equations like x to the 4th plus 6x squared plus 5 by using a proper substitution to convert it to a quadratic. We need to know how to work out the sums and products of the roots of the quadratic equations. And the final part of quadratics, which is similar to CSEC Mathematics, solving 2 equations simultaneously, one being linear and the other being nonlinear. Just like at CSEC Math, the second equation could be a quadratic equation, or as an advancement to the topic in Add Maths, it could be a circle. So we need to know how to handle the circle equation. For part C, inequalities, by using graphical or algebraic means, students should be able to find the range and domain of quadratic inequalities and even rational linear inequalities. Ax plus b divided by cx plus d is greater than 0. For the 4th one, Surds, indices and logarithms, students should be able to use the basic operations of add, take away, multiply, and rationalize surds. Students should be able to handle the laws of indices to solve exponential equations, linear or quadratic, to convert from the indices form to the logarithm forms or vice versa, and of course the laws of logarithms. Students should be able to solve logarithm equations and apply logarithms to solve problems such as linear reduction. T is equal to ax to the power b, and we can use logarithms to convert that to a linear form. And the last part of section 1 is part E, sequences and series. And in this, students need to know how to find the nth term in a sequence that a series is a sum of the sequence terms, APs, arithmetic progression, and geometric progression, GPs, and of course the nth term, the sum to the nth term, and the sum to infinity of these, and the final part to show divergence or convergence of the APs and GPs accordingly. As we look at the table, we can see the 5 subtopics are tested each year over the 5 years from May 2017 until 2022. Let's recall that in May 2020, there was no Paper 2 CSEC Additional Maths exam. And we can see when we're looking at functions that by May 2021, it was no longer tested or on the syllabus. May 2017, number 1a, the function f is defined by f of x is equal to 2x plus p all over x minus 1, where x is not equal to 1, and p is a constant. So we can tell that this falls under the subtopic of functions. Part 1. Determine the inverse of f of x. F of x is equal to 2x plus p all over x minus 1. So we can begin by putting brackets around the numerator and denominator, as it seems to help students who are confused. And what we want to do is make x the subject of the formula. So we can move the denominator across. So it's going to give us x minus 1 in brackets multiplied by f of x is equal to what is left on the right hand side, 2x plus p. And we can expand the brackets, so it gives us x by f of x minus 1 by f of x is equal to 2x plus p. And we can move all the x's on the left hand side, so we're going to get f of x minus 2x is equal to 1 f of x plus p. We can now factorize out the x, so that gives us x by f of x minus 2 is equal to f of x plus p. Remember, 1 f of x is the same as f of x. So x is equal to f of x plus p all over f of x minus 2. And we can replace the x by f inverse, and on the right hand side, replace f of x by x. So that gives us f inverse x is equal to x plus p all over x minus 2. So this is the inverse of the function. Part 2. If f inverse 8 is equal to 5, find the value of p. So we know the formula, which we just worked out in part 1. F inverse x is equal to x plus p over x minus 2. So let's substitute for x as being 8. So it's going to give us f inverse 8 is equal to 8 plus p all over 8 minus 2. And they told us the value of f inverse 8. So we can replace that. It's going to give us 5 is equal to 8 plus p all over, and what is 8 minus 2? 6. So we can solve for p. Let's carry the 6 across. The 6 is dividing on the right hand side, so we'll do the inverse of that, so it will multiply when we carry it across on the left hand side. So we're going to get 5 sixes is equal to 8 plus p. 30 is equal to 8 plus p. So p is equal to 30 minus 8, which is 22. And we can check that if we consider that p is 22 and we put it into the original equation f of x, it will give us 2x plus 22 over x minus 1. And if we substitute x as being 5, we're going to get 2 5s are 10 plus 22 is 32 over 5 minus 1, which is 4. 4 into 32 is 8. F of 5 is equal to 8, or f inverse 8 is equal to 5. So it checks out. Part B. Given that the remainder when f of x is equal to x cubed minus x squared minus ax plus b is divided by x plus 1 is 6. So we're looking at the remainder theorem. And that x minus 2 is a factor, so that's the factor theorem. Or it's the same, it just means that the remainder is 0. Determine the values of a and b. So what we want to do is be able to use the factor theorem or remainder theorem accordingly, generate two equations and solve them simultaneously. So let's begin. F of x is equal to, let's rewrite the formula. X plus 1 is a divisor, so we can use f of minus 1. And if we substitute that, we're going to get minus 1 cubed minus 1 squared minus a times minus 1 plus b. And we know f of minus 1, we know that the remainder is 6. So 6 is equal to minus 1 minus 1 squared is 1, so that's minus 1. Minus a times minus 1 is a plus b. So we can carry minus 1 and minus 1, which is minus 2 across. So we're going to 6 plus 2 is 8 is equal to a plus b. Or if we want, we can make b the subject of the formula by saying 8 minus a is equal to b. And for the second part of the information, x minus 2 is a factor. As such, x is equal to 2. So let's rewrite the formula. And then let's substitute f of 2 into there. So we're going to get 2 cubed minus 2 squared minus a times 2 plus b. And since it's a factor, f of 2 is 0. So 0 is equal to 2 cubed, which is 8 minus 4 minus 2a plus b. So 8 minus 4 is equal to 4. We carry it across. We can have minus 4 is equal to minus 2a plus b. So if we rewrite the second equation by substituting for b, which we got in the first part, then it will give us minus 4 is equal to minus 2a plus, and what is b? 8 minus a. So if we look at this line, we only have one unknown, which is a, so we can solve it. So we can carry the numbers across. So we get minus 4 minus 8, which is minus 12. And on the right-hand side, we are left with minus 2a minus a, which is minus 3a. So a is equal to minus 12 divided by minus 3. So a is equal to 4. And since we've solved for a, we can substitute into the first equation. We got 8 minus a is equal to b. And we just worked out a, so 8 minus 4 is equal to b, so b is equal to 4. So we found the solutions for both a and b. May 2017, number 1c. The values of the variables p and x in a table 1 obtained from an experiment are thought to obey a law of the form p is equal to a x to the power minus k. And we have the values of x and p as given in the table. Part 1. Use logarithms to reduce the equation to a linear form. So this clearly falls under the subtopic Surds, Indices and Logarithms. So let's write the formula p is equal to a x to the index minus k. And if we apply logs to both sides, we're going to get log p is equal to log a plus log x minus k. So remember the rule that if we have a product such as AB and we apply logs to it, then log AB is the same as log A plus log B. And that's what we've done with the right-hand side. And now we can apply the rule where if we have log to a power or an index, we can bring the index in front. Meaning log x to base n is equal to n log x. So if we write this line, it's going to give us log p is equal to log A minus k log x. And let's rewrite it. So it's going to give us log p is equal to minus k log x plus log a. It looks like the form y is equal to mx plus c, which is the general formula of a straight line graph. So we can consider that the y values will be log p, the gradient will be minus k, gradient being represented by m, the x values will be log x, and the y-intercept c is equivalent to log a. Part 2. Using a suitable scale, plot the best fit line of the equation in C part 1 on the graph paper. Use the space below to show your working. So let's take the table and apply logs to it. So log x, we're going to give us those values 0.2, 0.4 straight up to 1. And log p will give these values from 2.08 to 1.97. And let's plot the points and draw a line of best fit. Remember, a line of best fit is one in which we can draw a straight line through most of the points. And if there are any points that are remaining, that we should have the equal number of points above and below the line. Part 3. Hence, estimate the constants a and k. If we consider that the y-intercept c is equal to log a, so a is equal to 10 to the power c. And we know c, the y-intercept, to be approximately 2.1. Then if we use a is equal to 10 to the power 2.1, it's going to give us approximately a is equal to 125. For the gradient of the straight line graph, m is equal to change in y over change in x. And we know m, that is equal to minus k, will be equal to change in y. Let's look at this right angle triangle we're putting up here. So you can see the change in y, which is 2.1 minus 1.97. We're using the y-intercept and that fifth point, all over 0 minus 1. So that works out to be minus 0.13. Therefore, k is equal to 0.13. So we found the values for the constants a and k. May 2017, number 2a. The quadratic equation 2x squared plus 6x plus 7 is equal to 0 has roots alpha and beta. Calculate the value of 1 on alpha plus 1 on beta. So this clearly falls under the subtopic quadratics. So let's write the equation 2x squared plus 6x plus 7 is equal to 0. And this quadratic equation, we can consider the coefficient of x squared a to be 2, b is equal to 6, and c is equal to 7. And this follows from the general formula for quadratic equation ax squared plus bx plus c. So the sum of the roots will be equal to minus b over a, and we can substitute. It will be equal to minus 6 over 2, which works out to be minus 3. So if we add up the two roots of this quadratic equation, it's going to give us minus 3. And for the product of the roots, then it is equal to c over a, which is 7 over 2. We can now use these two pieces of information to solve for 1 on alpha plus 1 on beta, which is equal to, we can rearrange it, because if we're adding two fractions, then that's going to give us beta plus alpha all over alpha beta. And beta plus alpha is the sum of the roots, which is minus 3, divided by alpha beta, which is the product of the roots, which is 7 over 2. And if we're dividing fractions, we can rewrite it as minus 3 over 1 times 2 over 7, which works out to be minus 6 over 7. And it's more accurate to write this as a fraction rather than a decimal. Part B. Determine the range of values of x for which 2x plus 3 all over x plus 1 is greater than or equal to 0. Subtopic of inequalities. So when we're handling such a question, what we would like to do first of all is to get rid of the denominator. So the simplest way to do that is multiplying throughout by whatever the denominator is squared. That way, it's going to give us 2x plus 3 over x plus 1 multiplied by x plus 1 squared on the left-hand side is greater than or equal to 0 times x plus 1 squared on the right-hand side. So you're going to give us 2x plus 3 by x plus 1 on the left-hand side is greater than or equal to 0. And if we consider this to be a quadratic equation equal to 0, either x plus 1 is equal to 0, so x is equal to minus 1, or the other brackets, 2x plus 3 is equal to 0. So 2x is equal to minus 3, so x is equal to minus 3 on 2. So if we're sketching the quadratic graph, the coefficient of the x squared term in the graph is positive, so it's a U-shaped graph, cutting at the two roots of minus 1 and minus 1.5 or minus 3 on 2. And we'd like to determine where this is greater than or equal to 0, which means where are the y values positive. So if we look at the first root, minus 1 on the right-hand side, it will be everything to the right of that. So x will be greater than or equal to minus 1. And on the root on the left-hand side, it will be to the left of that. X will be less than or equal to minus 3 on 2. And when the x value falls within those ranges which we have in blue, that indicates where our inequality is greater than or equal to 0. Thus, minus 3 on 2 is greater than or equal to x, which is greater than or equal to minus 1. So we're just combining two inequalities and writing it in one line. 1c. An accountant is offered a 5-year contract with an annual increase. The accountant earned a salary of $53,982.80 and $60,598.89 in the third and the fifth years respectively. If the increase follows the series, calculate the amount paid in the first year. So if we're going to do that, let's consider that we know t to the 5, which is a r to the 4th. Remember that the general formula for a GP or geometric series, t to the n is a r to the n minus 1. And if we divide it by t to the 3, which is equal to a r squared, and when we substitute the right hand side, the a's will cancel, and r squared into r fourth is r squared. So we can now solve for r squared and find the square root. So r, the common ratio, is equal to 1.06. So what that means is whatever the first term is, when we're going to get the next term, we multiply by 1.06. And we're going to get the following term, we multiply by 1.06 continuously. And that is our geometric series. So since we know r, we can substitute into either t to the 3 or t to the 5, any one. So let's consider t to the 3 is equal to ar squared. And we know t to the 3 is $53,982.80 is equal to a times r squared 1.06 squared. As such, a, which is the same thing as t to the 1, the first term, is equal to $48,044.50. Part 2, the total salary at the end of the contract. So we want to find sum to the n. Remember, that's the formula that's given in the formula sheet. So a r to the n minus 1 all over r minus 1. And the first line of the question states an accountant is offered a 5-year contract. So that means the end of the contract is that n is equal to 5. So s to the 5 is equal to, and we can substitute for a, r to the 5th minus 1. So it will be $48,044.50 by 1.06 to the 5th power minus 1 all over 1.06 minus 1. So s to the 5th, which means the total salary that the accountant received after 5 years, is equal to $270,831.31. May 2018, number 1a, part 1. Given that f of x is equal to x squared minus 4, where x is greater than or equal to 0, find f inverse x, stating its domain. So this subtopic is functions. So let's write the equation f of x equal to x squared minus 4, which we can see is a quadratic equation. And if we want to find f inverse, let's make x the subject of the formula. So f of x plus 4 is equal to x squared. So x is the square root of f of x plus 4. And let's convert it. Let's replace x by f inverse x, and let's replace f of x by x. The square root of x plus 4 is equal to f inverse x. And the domain, which are the x values, will be where it is greater than or equal to minus 4. Because if the x value is less than minus 4, then that would work out to be negative, and we cannot get the square root of a negative number at this Add Maths level. Part 2, on the grid provided, sketch f inverse x. Now let's recall that if the function is x squared minus 4, then that's the same as x squared minus 2 squared. So that will be the difference of squares. So the factors will be x plus 2 by x minus 2. And if we're making a sketch of that, let's have that in a red line coming up. It will be cutting at 2. And if we look at the domain, x was greater than or equal to 0. And it cuts at minus 4. In order to get the inverse of a function, we look at this blue line we're bringing up, which indicates the line y is equal to x. And that is necessary because the inverse of a function, which we're plotting in green, will be the reflection of what we have in red, the original function, f of x, about the mirror line, y is equal to x. So we're reflecting the red line about the blue line, where it was cutting at 2 on the x-axis, it will now be cutting at 2 on the y-axis. Also, where it is cutting at minus 4 on the y-axis, when we reflect it, it will be cutting at minus 4 on the x-axis. The red line cut the blue line, which will be at 2.25. Then the green line will be doing the same thing, cutting at 2.25. Part 3. State the relationship between f of x and f inverse x. And as we stated before, they are a reflection of each other about the mirror line, which we have in blue, which is the line y is equal to x. May 2018, number 1b. Derive the polynomial p to the x of degrees 3, which has roots equal to 1, 2, and minus 4. So what that means that when x is equal to 1, this implies that it has a factor x minus 1. And when x is equal to 2, it implies that the factor is x minus 2. And when x is equal to minus 4, it means that the factor is x minus minus 4, which is x plus 4. Remember, the polynomial has degree 3, which means it's a cubic equation, or x to the power 3. So it will be the multiplication of 3 linear factors. So p to the x is equal to x minus 1 by x minus 2 by x plus 4. So we can clearly see that number 1b is dealing with the subtopic of quadratics. Now number 1c, an equation relating v and t is given by v is equal to k a to the power t, where k and a are constants. Part 1. Use logarithms to derive an equation of the form y is equal to mx plus c that can be used to find the values of k and a. And this was a similar question to that which appeared in May 2017, which we answered earlier. So v is equal to k a to the power t. And if we apply logarithms to both sides, it's going to give us log v is equal to log of k a to the power t. Remember the rule that if we're applying logarithms to a product such as ab, so log of ab is equal to log of a plus log of b. So we can rewrite that log v is equal to log k plus log a to the power t. And if we have log a to the power t, then that's equal to bringing the t in front. So we can rewrite that line, log v is equal to log k plus t times log a. And let's rewrite it to look like a straight line graph. So log v is equal to t log a plus log k, where log v will represent y, t will represent m, the gradient of the graph, log a will be represented by x, and c, the y-intercept, is log k. Part 2. If a graph of y versus x from equation in part C, part 1, is plotted, a straight line is obtained. State an expression for the gradient of the graph. So let's rewrite the equation. Log v is equal to t log a plus log k. And if we link it to the general equation of a straight line graph, that indicates that the gradient m is equal to t. May 2018, number 2a, part 1. Given that g of x is equal to minus x squared plus x minus 3, express g of x in the form a x plus h all squared plus k, where a, h, and k are constants. So if we're looking at this form, it means we're looking at completing the square. And there are multiple ways to do this. So let's write the formula again. G of x is equal to minus x squared plus x minus 3. There are some students who get major problems with this. So let's try a simple method where we extract the coefficient of the x squared. So it's going to give us g of x is equal to minus x squared minus x minus 3. As such, we found a already. A would be what is outside the brackets, which is minus 1. So we're really considering that first set of brackets. So let's put some curly brackets around it. So we're going to get minus by x squared minus x minus 3. These curly brackets are just to help our students who are getting major problems. Since we're using this method to complete the square, so we're going to manipulate this by finding half of the coefficient of the x term. And if the coefficient of the x term is minus 1, then we're going to say minus a half all squared minus minus a half squared. So these things will actually cancel out each other. So we're not actually changing the value of the formula. Then let's remove the curly brackets. So we're going to get minus by x squared minus x plus a half squared. And minus times minus a half squared is plus a half squared, or plus a quarter, minus 3. So the trick in it was looking at the coefficient of the x term, which is minus 1 in this case, and finding half of that coefficient. Minus 1 by x minus a half squared, and plus a quarter minus 3 is minus 11 on 4. So we know a, which is minus 1, h, which is minus a half, and k, which is minus 11 on 4. Part 2. On the grid provided, sketch the graph of g of x, showing the maximum point and the y-intercept. And what we can recognize is the coefficient of this quadratic is negative, so that means it's an inverted U-shaped graph, and the y-intercept works out to be minus 3, as we see from the original equation, minus x squared plus x minus 3. So we know those two bits of information from there. So clearly, if it's a U-shaped graph, we're going to have a maximum value. And in order to get that maximum value, when we look at the completed square form, which we have in red there, the brackets must work out to be 0. So in order to get the brackets to be equal to 0, that means x is equal to a half. So that indicates that's the maximum value, or 0.5. And when x is equal to a half, the brackets works out to be 0. So g of x is equal to minus 11 on 4, which is minus 2.75. So our sketch here shows the two things they want, the maximum point, which we can write in terms of fractions, and our y-intercept. May 2018, number 2b. In a geometric progression, the third term is 25, and the sum of the first and second terms is 150. So we can tell that this deals with the subtopic of series and sequences. Determine the sum of the first four terms given that r is greater than 0. We know t to the 3, the third term, is equal to ar squared, and that's the formula that's given. T to the n is equal to ar to the n minus 1. It's given in the formula sheet. And we know the third term, so we can substitute. 25 is equal to ar squared. And we can make a the subtopic formula, so that will give us 25 over r squared. That will help us to manipulate and solve. We also know that the first term plus the second term, t1 plus t2, is equal to 150. t1 is a plus t2 is ar, a times r, is equal to 150. And we can substitute for a, so that will be 25 on r squared plus 25 on r squared times r, which is equal to 150. So that gives us 25 on r squared plus 25 on r is equal to 150. And easiest way to solve, we can multiply throughout by r squared. So that's going to give us 25 plus 25r is equal to 150r squared. Remember, we multiplied r squared for each of the terms, on the left and the right. If you want to solve this quadratic equation, then we can move all the terms across to leave one side equal to 0. So that gives us 0 is equal to 150r squared minus 25r minus 25. And we can divide throughout by 25 so that we're going to get the same answer, but we're working with smaller numbers. So if we divide throughout by 25, 0 over 25 is 0, is equal to 25 into 150, 6r squared minus r minus 1. And we can easily factorize that. That's going to give us 3r plus 1 by 2r minus 1. If you're getting problems with factorization, you can go back to my other channel where we did Maths CSEC past papers and look at the many questions we did with factorization. Either 3r plus 1 is equal to 0, which means that 3r is equal to minus 1. So r is equal to minus 1/3. Or 2r minus 1 is equal to 0. So 2r is equal to 1, which means that r is equal to a half. And if we go back to our question above, the last thing they told us was r was greater than 0. As such, r is equal to a half. And if we know r is equal to a half, we can substitute into the equation a is equal to 25 on r squared. That's fine for a. So a is equal to 25 over a half squared. A half squared is a quarter. 25 divided by a quarter is the same as 25 multiplied by 4. So a, which is the first term, is equal to 100. And now we have another formula for the sum of the n terms, which is given in the formula sheet. S to the n is equal to a r to the n minus 1 all over r minus 1. And we know a, that worked out to be 100. And we know r, which is a half. And we want to find for the first four terms. So n is 4. So s to the 4 is equal to 100 by a half to the power 4 minus 1 all over a half minus 1. Which gives us 100 by a half squared is 1/16. 1/16 minus 1 is minus 15 over 16. Gives us 187.5. So that will be the sum of the first four terms of this geometric series. And part C, if alpha and beta are the roots of the equation 2x squared minus 5x plus 3 is equal to 0, determine the value of 1 on alpha squared plus 1 on beta squared. So we can see that this is dealing with product and sum of roots, which falls under the subtopic of quadratics. So let's rewrite the equation 2x squared minus 5x plus 3 is equal to 0. And since this is in quadratic form, we know a, the coefficient of x squared, is 2, b is equal to minus 5, and c is equal to 3. So the sum of the roots, meaning alpha plus beta, is equal to minus b over a, which is equal to minus of minus 5 on 2, a minus, that gives us a plus, so we're going to be left with 5 over 2. And the product of the roots, alpha times beta, is equal to c over a, which is 3 over 2. So if you want to determine the value of 1 on alpha squared plus 1 on beta squared, by adding fractions, it's going to give us alpha squared, beta squared in the denominator. So that will give us beta squared plus alpha squared all over alpha squared, beta squared, because this is just simply adding two fractions. And we can manipulate the numerator, so alpha squared plus beta squared plus 2 alpha beta minus 2 alpha beta all over alpha beta squared. And why we're doing that with the numerator, this gives us alpha plus beta all squared minus 2 alpha beta all over alpha beta squared. So alpha plus beta is the sum of the roots and alpha beta is the product of the roots, which we've worked out above. So we can substitute, and that will give us 5 on 2 squared minus 2 times, what is product of the roots? 3 over 2 all over 3 over 2 squared. And 5 on 2 squared is 25 on 4 minus 2 times 3 on 2 is 3. So we get 25 on 4 minus 3, which is 12 on 4, all over 3 on 2 squared, which is 9 on 4. And if we're dividing fractions, you can use our calculator. We can just work it out. 13 on 5 times 4 on 9. The 4's cancel, so we're left with 13 on 9. So that will be the value of 1 on alpha squared plus 1 on beta squared. May 2019, number 1a. The function f is such that f of x is equal to 2x cubed plus 7x squared plus 3x. Part 1. Determine all the linear factors of f of x. So we can recognize that this is part of algebra, this subtopic in this first section of the syllabus. If we want to find the linear factors, let's make f of x equal to 0. So 0 is equal to 2x cubed plus 7x squared plus 3x. And if we factorize out the x, it's going to give us 0 is equal to x by 2x squared plus 7x plus 3. And we can factorize that quadratic, which is in the brackets. So we get 0 is equal to x by 2x plus 1 by x plus 3. Therefore, x, 2x plus 1, and x plus 3 are the 3 linear factors of f of x. Part 2. Compute the roots of the function f of x. Either x is equal to 0 or 2x plus 1 is equal to 0, which means that 2x is equal to minus 1 and x is equal to minus a half, or x plus 3 is equal to 0, so x is equal to minus 3. So the roots are 0, minus a half, and minus 3. And let's bring up a little sketch of this so you can see what the cubic equation looks like. May 2019, number 1b. Two functions are such that g of x is equal to x squared minus x and h of x is equal to 2x minus 3. Part 1. Determine g h of x. So we can see that this is a functions question. And let's write the composite function g h of x. And what is the first function that's actually acting on x? It will be h. So we can rewrite that h of x is equal to 2x minus 3. That was given above. And now we can substitute for h of x. So let's show that with the blue arrow coming down that we're going to replace it and write g of 2x minus 3. And we have the function. Let's rewrite that. From above, g of x is equal to x squared minus x. And we want to find g of 2x minus 3. So wherever we have x, we're going to substitute it for 2x minus 3. So that's going to give us 2x minus 3 squared minus 2x minus 3. And we can expand the right-hand side, so it's going to give us 4x squared minus 12x plus 9 minus 2x plus 3. Because that minus 1 is multiplying everything inside the last set of brackets. And we can simplify. So g of 2x minus 3 is equal to 4x squared minus 12x minus 2x is minus 14x plus 9 plus 3 is plus 12. So the composite function g h of x is equal to 4x squared minus 14x plus 12. Part 2. Given that hg of x, another composite function, is equal to 2x squared minus 2x minus 3, show that the values of x for which hg of x is equal to 0 can be expressed as 1 plus or minus the square root of 7 all over 2. So if we're looking at hg of x, we know it's equal to 0, so we can rewrite that. Let 0 is equal to 2x squared minus 2x minus 3, where a is equal to 2 b is equal to minus 2, and c is equal to minus 3. And that goes from the general function x is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. And we can substitute. So x is equal to minus of minus 2 plus or minus the square root of minus 2 squared minus 4 times 2 times minus 3 all over 2 times 2. Be careful not to mix up a and b values. One is plus 2 and one is minus 2. So if we simplify, x is equal to a minus is a plus, so 2 plus or minus 2 squared is 4, minus 4 times 2 is minus 8 times minus 3 is plus 24. 4 plus 24 is 28. So 2 plus or minus the square root of 28 all over 4. We can rewrite the square root of 28 as the square root of 4 times 7, and that will give us 2 plus or minus the square root of 4 times 7 all over 4. So x is equal to 2 plus or minus 2 root 7, because the square root of 4 is equal to 2. And if we factorize out the 2 on the numerator, we're going to get 2 by 1 plus or minus the root of 7 all over 4. And they're going to cancel out. So we'll be left with 1 plus or minus the root of 7 all over 2, which is what we needed to prove. So we can bring up a square or write QED to show that we have completed the proof. Part C. Solve 3x log 2 plus log 8 to the power x is equal to 2. And of course, this falls within the subtopic of Surds, Indices and Logarithms. So how do we manipulate this? Let's rewrite the equation we just got. 3x log 2 and so forth. If we recall the rule, log x to the power n is equal to n log x, meaning if we have an index, we could bring it in front. Then we can rewrite it. So we get 3x log 2 plus x log 8 is equal to 2. And we can factorize the x. So it will give us x by 3 log 2 plus log 8 is equal to 2. And using the same law, we can move the 3 from in front and make it 2 to the power 3. So we get x log 2 to the power 3 plus log 8 is equal to 2. And of course, 2 to the power 3 or 2 cubed is 8. So we can rewrite it x by log 8 plus log 8 is equal to 2. Which means x by 2 log 8 is equal to 2. So x is equal to 2 over 2 log 8. And the 2's cancel. As such, x is equal to 1 over log 8. We can leave it like this, or we can use our calculators and solve further. May 2019, number 2a, part 1. Express f of x is equal to minus 2x squared minus 7x minus 6, a quadratic equation, in the form a x plus h squared plus k. So we're looking at the subtopic of quadratics and particularly completing the square. There are multiple methods to solve this question. In May 2018, number 2a, earlier on in this video, we looked at expanding the quadratic and equating it. In this question, we'll just be using the formulas for h and k to solve. So let's rewrite f of x is equal to minus 2x squared minus 7x minus 6. And we've highlighted the coefficients of x squared, x, and x to the power 0. So let a be equal to minus 2, the same color as above for us to follow what's happening. For b is equal to minus 7, and c is equal to minus 6. So we've already found for a is equal to minus 2. We just need to find for h and k. So from the quadratic formula, x is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. H is equal to b over 2a. It comes directly from the formula. And we just substitute. We know b, we have it in green as minus 7. All over 2 times, what's a? Minus 2. So that will be minus 7 over minus 4. The negatives cancel, so h is equal to 7 over 4. And for k, that is equal to whatever is in the square root sign reversed. So that will be 4ac minus b squared all over 4a. And if we substitute, 4 times what was a, that was in red, that's minus 2, times c, which is in blue, that's minus 6, minus 7 squared, all over 4 times minus 2. So the numerator is 4 2s are 8, 8 6s are 48, plus 48 minus 7 squared is 49. 48 minus 49 is minus 1, and the denominator is 4 times minus 2 is minus 8. So minus 1 over minus 8 is equal to 1/8. So we found A as minus 2, H as 7 over 4, and K as 1/8. So we can rewrite f of x in the form that they require. So f of x is equal to minus 2 by x plus 7 over 4 all squared plus 1/8. Part 2. State the maximum value of f of x. Since a is negative, it means that this is an inverted U-shaped graph, which means that it has a maximum. So in order to get the maximum value of f of x, make whatever is in the brackets equal to 0. And if that is 0, then what are we left with? F of x is equal to 1/8 or 1/8. That will be the maximum f of x or y value. Part 3. State the value of x for which f of x is a maximum. And we just said for f of x to be a maximum, the brackets has to be equal to 0. So we can write that x plus 7 over 4 is equal to 0. So x is equal to minus 7 over 4. Part 4. Use your answer in A part 1 to determine all values of x when f of x is equal to 0, or when it cuts the x-axis. So let's rewrite the formula. Minus 2 by x plus 7 on 4 squared plus 1/8 is equal to 0. And we're simply transposing in order to make x the subject of the formula. So the first thing to carry across will be the plus 1/8. Minus 2 by x plus 7 over 4 squared is equal to minus 1/8. The next thing to carry across will be the minus 2. Minus 2 is multiplying on the left-hand side. So we want to carry it across. So we get the multiplicative inverse, which means it's dividing. So we're left with x plus 7 over 4 all squared is equal to minus 1/8 times minus 1 over 2, which works out to be a minus, a plus. 8 2s are 16, 1/16. Therefore, x plus 7 over 4 is equal to, we're going to get rid of the square sign, carry it across, it will be square root. So it will be equal to plus or minus 1/16, which works out to be plus or minus 1/4 or a quarter. And that gives us x is equal to minus 7 over 4 plus or minus 1/4. So either x is equal to minus 7 over 4 plus 1/4, which works out to be minus 7 plus 1 is minus 6 over 4. So x is equal to minus 3/2 or minus 1.5. Or x is equal to minus 7 over 4 minus 1/4. Minus 7 minus 1 is minus 8/4, which is equal to minus 2. So we've gotten the roots at minus 1.5 and minus 2. Part 5. Sketch the function f of x and show your solution set to A part 4 when f of x is less than 0. So we want to know when f of x is negative. So let's bring up the graph, and we see we have the two roots highlighted at minus 2 and minus 1.5 as we worked out just above, and it's cutting at minus 6. And we want to highlight where is it that f of x is negative. So if we look at the root on the right side, minus 1.5, then everything to the right of that, we bring it up in blue. That is where f of x is negative or less than 0. And if we look at the root on the left, minus 2, then everything to the left of that would be where f of x is less than 0. Thus, when minus 3 and 2 is less than x and x is less than minus 2, this is the solution set for when f of x is less than 0. Or where are the y values of the graph negative. May 2019, number 2b. A geometric series can be represented by y on x plus y squared on x cubed plus y cubed on x to the power 5 plus so forth. Prove that sum to infinity is equal to xy by x squared minus y to the index minus 1. So we recognize it's a geometric series, so it falls under the subtopic of sequences and series. And what do we know? We know the first term. T to the 1 is y on x. And the second term is y squared on x cubed And the third term, t to the 3, is y cubed on x to the 5th. And if we consider for a geometric series, a times r is equal to t to the power 2. And this comes from the formula which is given that ar to the n minus 1 is equal to t to the n for GP. And we can substitute a is t on 1. So t on 1 by r is equal to t on 2. R is equal to t on 2, the second term, divided by the first term. And if we substitute, r is equal to y squared over x cubed divided by y over x, because those were second terms and first terms respectively. And if we divide in fractions, we can rewrite y squared over x cubed multiplied by the reciprocal, x over y. And y in the denominator cancels with one of the y's in y squared, and x cancels with one of the x in the denominator, so we get y over x squared. So now that we know our common ratio, then the sum to infinity, which is a formula is given in the formula sheet, is equal to a over 1 minus r. And we know a and r, so we can substitute. So the sum to infinity is equal to y over x, all over 1 minus, what's r? Y over x squared. And that gives us y over x divided by, we can simplify the denominator. So that will be x squared minus y all over x squared. Since we're dividing fractions, we can rewrite it as y over x multiplied by x squared over x squared minus y. And the x's cancel. We're left with xy over x squared minus y. Or xy is equal to x squared minus y to the power minus 1. So we can bring up a small square to indicate that we have proven what was required. Or you can write QED. Made number 1a, part 1. Determine the remainder when f of x is equal to ax cubed plus 7x squared minus 7x minus 3 is divided by x minus 1. So let's rewrite the function. F of x is equal to ax cubed and so forth. And if it's dividing by x minus 1, then we can use x is equal to 1. So let's substitute that. F of 1 is equal to a by 1 cubed plus 7 by 1 squared minus 7 by 1 minus 3. So f of 1 is equal to 1 cubed is 1 times a is a, plus 1 squared is 1 by 7 is 7, minus 7 minus 3. So f of 1, its remainder, is equal to a, 7 minus 7 is 0, minus 3. Part 2. If the remainder when f of x is divided by x plus 3 is equal to the remainder determined in a part 1, find the value of a. So let's rewrite the function again. F of x equal to ax cubed plus 7x squared minus 7x minus 3. And since we're dividing by a linear factor x plus 3, let's make x equal to minus 3. So we substitute and we get f of minus 3 is equal to a by minus 3 cubed plus 7 by minus 3 squared minus 7 by minus 3 minus 3. And we know the remainder for f of minus 3 is the same as in part 1. So we can substitute for that. We get a minus 3 is equal to minus 3 cubed is minus 27a. Minus 9 squared is 9 by 7 is plus 63. 7 3s are 21 plus 21 minus 3. And if we put all the a's on one side and all the numbers on the other side, we should be able to solve. So a plus 27a is equal to, carry the minus 3 across, we're going to get 3 plus 63 plus 21 minus 3. A plus 27a is equal to 28a. 3 minus 3 cancels, so 63 plus 21 is 84. So 28a is equal to 84, a is equal to 3. Part B. Consider the function g of x equal to x squared plus m plus 4 x plus 4m equal to 0, which has real and equal roots. Use the discriminant of the given equation to determine the values for m. You may use the grid provided to assist you. So part A was dealing with algebra, and this part B is dealing with quadratics. And they want us to use the discriminant. So we know from the function that the coefficient of x squared is 1. So we say A is equal to 1, B is equal to m plus 4, and C is equal to 4m. And to recall from the quadratic formula, x equal to minus b plus or minus the square root, whatever is in the square root is the discriminant. So we can write discriminant is equal to b squared minus 4ac. Since it has real and equal root, the discriminant works out to be 0. So 0 is equal to, and we just substitute, m plus 4 squared, that's b squared, minus 4 times 1 times 4m. And we can expand. 0 is equal to m squared plus 8m plus 16. Minus 4 by 4 is minus 16m. So that gives us 0 is equal to m squared minus 8m plus 16. And we can factorize, so you're going to get 0 is equal to m minus 4 all squared. So m is equal to 4. So if we bring up a little sketch to show you that this quadratic, we know A is positive, so it's a U-shaped graph, and it's cutting at minus 4. May 2021, number 1C. Let h of x equal to 2x squared plus 8x minus 10. Part 1. Express h of x in the form a, x plus b all squared plus c. So we can see that this falls under quadratics and specifically completing the square. In this video, this is the third time this question came, the first being in May 2018, and we showed the method of expanding it in order to solve the question. In May 2019, the following year, we used the quadratic formula to solve, and in this year, we'll show a third method by using algebra tiles. So let's begin. So let's rewrite the formula, h of x equal to 2x squared plus 8x minus 10, and the first thing to do is factorize out the coefficient of x squared. So let's pull out the 2. So we're going to get h of x is equal to 2 by x squared plus 4x minus 10. So we're leaving the minus 10 alone on the right hand side. If it's 2 times a brackets, then it means we're adding the brackets twice. So we can rewrite it, h of x is equal to x squared plus 4x plus x squared plus 4x again minus 10. So let's see if we could deal with one of these brackets, x squared plus 4x. So let's bring up a yellow tile to indicate x squared with dimensions x by x. And what we're trying to do is to maintain a square as much as possible. So let's bring up 2x, and we could bring up one on the right hand side being vertical and one below horizontal, both with dimensions 1 by x. And we're now going to bring up 2 of them again. So one more on the right hand side and one more on the left hand side. And we're still trying to maintain a perfect square. So we're bringing up this dotted line so we can see that's what we're trying to fill. So in this square, we have x squared and we have 4 x's. So we have x squared plus 4x. And since we have it twice, let's bring it across so we can see 2 sets of them. And how do we represent minus 10? Well, first of all, using algebra tiles, generally when we have something negative, we use the color red. And when it's positive, we could use any of the other colors. So we're going to bring up 10 small squares to represent minus 10. So the first diagram on the left indicates x squared plus 4x. The middle one indicates x squared plus 4x again. And then the one on the right with the red is minus 10. So in all, we're going to get 2x squared plus 8x minus 10. So you can still see that everything is equivalent. Now what we want to do is fill the squares. So how do we do that? Well, first of all, let's bring up plus 1 and a minus 1. So using those colors there, if we're adding plus 1 and minus 1, we're actually adding 0. So we're not actually changing the value of anything. And we're going to bring up 4 of those. So for the first diagram, we actually have plus 4 minus 4, which is equal to 0. So we haven't changed anything. And we can use that and take the green ones and fill them, because we want to use plus 4 in there to fill the rectangle. If the dimensions were negative, then we'll be using the red ones, which are negative. So that gives us a perfect square, minus 4. And we do the same in the second one. We bring up plus 1 and minus 1, and we repeat that. So we're actually not changing the total value, it's still 0. So that means plus 4 minus 4 is equal to 0. Let's fill the empty space to make a perfect square. So the first diagram in all means x plus 2 all squared minus 4. And the second diagram is the same thing, x plus 2 all squared with 4 red squares on the outside minus 10. And we can now remove the brackets and simplify. So you're going to get x plus 2 squared plus x plus 2 squared. So you're going to get 2 of those. So you're going to get 2 by x plus 2 all squared minus 4 minus 4 minus 10. So h of x is equal to 2 by this perfect square x plus 2 all squared minus 18. And we've completed the square. Part 2. State the minimum value of h of x. So if we look at h of x, we can see the coefficient of a is positive, so it's a U-shaped graph, meaning we're going to have a minimum value. In order to get the minimum value, we need to make the brackets equal to 0. That will give us our smallest h of x value. And the smallest value of a square number is 0. So h of x minimum value is minus 18. And part 3, determine the value of x for which h of x is a minimum. And we just indicated in order for it to be a minimum, the brackets must be equal to 0. So x plus 2 must be equal to 0. Therefore, x is equal to minus 2. So I'm going to bring up a sketch to give you an indicator of what the graph looks like. And of course, it's a U-shaped graph. If we look at the original equation, h of x, we recognize that the y-intercept is minus 10. So the graph is cutting at minus 10. It's U-shaped. And its minimum point is minus 2 minus 18, which were the values that we found in part 2 and part 3. So completing the square is just another way of shifting the normal quadratic into a form where we can easily identify the minimum point. May 2021, number 2a. Given that log 6 plus the root of 12 to base 2 minus log 3 plus root a to base 2 is equal to log 10, find the value of a. So this falls under the subtopic, Surds, Indices and Logarithms. So let's rewrite it. And when we look at it, we see that on the left-hand side, both of them are to base 2. And there's a rule where if two logs have the same base and they're subtracting, then when we combine them, they're going to divide. So we're going to get log 6 plus root 12 all over 3 plus root a to base 2 is equal to log 10 to base 10. Now it's understood that it's base 10. So let's rewrite it, and we recognize that log 10 to base 10 is 1. So if we want to remove the logs, we can carry the 2, which is the base, across. It will give us 2 to the power 1. We can also manipulate inside the root, so we get 6 plus 4 times 3 over 3 plus root a. So that gives us 6 plus 2 root 3, because the square root of 4 is 2, over 3 plus root a is equal to 2, because 2 to the power 1 is 2. So we can move the denominator across, so it will give us 6 plus 2 root 3 is equal to 2 times 3 plus root a. And we can expand, so we're going to give us 6 plus 2 root 3, 2 3s are 6, plus 2 root a. So we can solve for a. If you look at the left-hand side and right-hand side, they look identical. So a is equal to 3. Part B. Determine the set of values for which 2 minus x all over 4x minus 9 is less than 0. So we can see there's an inequality. So how do we solve this? First of all, let's multiply throughout by whatever the denominator is, all squared. So that will give us 2 minus x all over 4x minus 9 times 4x minus 9 squared on the left-hand side and on the right-hand side. So the right-hand side works out to be 0. 0 times anything is 0. And on the left-hand side, the denominator cancels. So we're going to get 2 minus x by 4x minus 9 less than 0. Let's consider 2 minus x by 4x minus 9 is equal to 0. And that way either 4x minus 9 is equal to 0. So 4x is equal to 9. So x is equal to 9 over 4. So we're actually solving for this quadratic to find the roots. Or 2 minus x is equal to 0. So 2 is equal to x. So we now, if we bring up a sketch, we can see the roots at 2 and 9 on 4, or 2 1/4, or 2.25. And we want to find where this quadratic is less than 0. So if we look at the root 2.25, anything to the right of it, which we'll bring up in blue, indicates where f of x is less than 0. So x is more than 9 on 4, or more than 2.25. And if we look at the other root, x is equal to 2 on the left-hand side. In order for f of x to be less than 0, then it's anything to the left of that. So we can rewrite this in one line. Thus, 9 on 4, or 2.25, is less than x, and x is less than 2. So this shows the set of values where f of x is negative. May 2021, number 2C. Alice deposited $4,000 into her new savings account at Bank of Fortune, which pays interest at 8% per annum. The bank's compound interest is represented by the geometric progression A is equal to P, open brackets 1 plus R on 100 to the power T, where A is the amount of money accumulated after T years, R, the percentage rate of interest per annum, and T, a positive integer, the time in years. Determine the number of years it would take Alice's money to at least triple. So let's write the formula. A is equal to P, open brackets 1 plus R 100 to the power T. And what we're saying is at some point, the amount will be 3 times what it started with, 3 times the principal. So we can substitute 3P is equal to P by 1 plus 8 on 100, because it told us the percentage is 8% in the first line, and the time is T. That's what we want to find. So if we carry the P across, the P will cancel, so we'll get 3 is equal to 1.08 to the power T. So this question is part of series and sequences because it has geometric progression. But at this point in time, if we want to find for T, that means we're dealing with surds, indices, and logarithms. So we can move the 1.08 across and make it the base by putting logs on both sides. So we're going to get log 3 to base 1.08 is equal to T. And if we're using our calculators, it will be log 3 to base 10, and base 10 is understood, over log 1.08 to base 10. So that works out to be 14.3 years is equal to T. So the question asks, determine the number of years it would take for Alice to at least triple her money. It will be 15 years. May 2022, number 1A. Consider the quadratic equation qx squared minus 4px plus pq squared is equal to 0, where p and q are both positive integers. Part 1. Express the sum and product of the roots of the equation in terms of p and q. So let's rewrite the equation. Qx squared minus 4px plus pq squared is equal to 0. Let's recall the general equation of a quadratic is ax squared plus bx plus c, where a, b, and c are the coefficients. So let's use that. So a, in this case, is equal to q, b is equal to minus 4p, and c is equal to pq squared. So the sum of the roots would be minus b over a. So let's substitute. It's going to give us minus 4p all over q. So the sum of the roots is 4p on q. Product of the roots is equal to c over a. And if we substitute, it's going to give us pq squared over q. And the q's cancel, so the product of the roots is equal to pq. Part 2. Determine the value of q such that the sum of the roots is equal to the product of the roots. So let's write sum of the roots is equal to the product of the roots. So 4p on q is equal to pq. And 4p is equal to pq squared because we're carrying the q across. And if we move everything across to the right hand side, 0 is equal to pq squared minus 4p. And if we factorize out the p, it's going to give us 0 is equal to p by q squared minus 4. Since p is not equal to 0, because in our top line they said that both of them are positive integers, it means that the brackets must be equal to 0. So q squared minus 4 is equal to 0. So q is equal to the square root of 4, which is plus or minus 2. And just as we said above in the top line, that q is a positive integer, then q could only be plus 2. Part 3. If the sum of the roots of the equation is 20, use your answer from A part to determine a value for p. So the sum of the roots is equal to 4p over q. And let's substitute. 20 is equal to 4p over 2. 2 into 4 is 2, and if we carry it across, so we get 10 is equal to p. Part 4. Hence, express the given equation in terms of its numerical coefficients. So if we rewrite our equation, qx squared minus 4px plus pq squared, and we substitute, we know q is equal to 2, and we know p is equal to 10, so that will give us 2x squared minus 4 by 10x plus 10 by 2 squared is equal to 0. So that gives us 2x squared minus 40x plus 2 2s are 4 by 10 is 40 is equal to 0. May 2022, number 1b. A series is given by 25 minus 5 plus 1 minus 1/5 plus 1 over 25, etc. Part 1. Show that this series is geometric. So of course this falls under the topic of series and sequences. So if the series is geometric, then it has a common ratio. Then r would be equal to t to the n plus 1 over t to the n. So if we use r1 is equal to t2 over t1, which is minus 5 over 25. Therefore, r1 is equal to minus 1/5. And we use r2 as a common ratio between the third term and the second term, and we substitute 1 over minus 5. So r2 works out to be minus 1/5. Therefore, the common ratio remains the same. r1 is equal to r2. So we've proven that it's a geometric series. Part 2. Calculate the sum to infinity of the series, giving the answer to 2 decimal places. And the sum to infinity is equal to a over 1 minus r. And this is a formula that's given in the formula sheet. So let's substitute because we know a is the first term, and we know r, which we just worked out. So sum to infinity is equal to 25. That's the first term over 1 minus 1/5. And 1 minus 1/5 is equal to 1 plus 1/5, which is 6 over 5. So 25 divided by 6 over 5 is equal to 25 times 5 over 6. So the sum to infinity is equal to 125 over 6. And this is a more accurate answer, leaving it as a fraction, than converting it to a decimal. Part C. A recent university graduate was offered a starting salary of $720,000 for the first year, with the increases of $5,000 at the start of each year thereafter. Determine the number of years to the nearest whole number that it would take for her annual salary to be 20% greater than her salary in the first year. So let's write t to the 1 of starting salary is equal to e is equal to $720,000. And what we want to find is t to the nth year, which is 1.2 times t to the 1, which is 20% more than her starting salary. So we know the formula t to the n that's given in the formula sheet, so let's write that a plus n minus 1 d is equal to 1.2a. Let's make n the subject of the formula. So we carry across the a, so we get n minus 1d is equal to 1.2a minus 1a. So n minus 1d is equal to 0.2a. As such, n minus 1 is 0.2a over d. And n, which is what we want to find, the nth year, is 0.2a over d plus 1. Now we can substitute. N is equal to 0.2 times 720,000 divided by the common difference. And the common difference is 5,000 because each year she's increasing by that amount, plus 1. So n works out to be 29.8 years, so n is approximately 30 years. May 2022, number 2a. When a polynomial 2x cubed minus 3x squared minus cx plus d is divided by x plus 1 and also divided by x minus 2, the same remainder of 64 is obtained. Determine the value of c and d. So we can recognize that this is a remainder theorem question, which falls under the subtopic of algebra. So let's write the formula. Let f of x equal to the cubic equation that they gave us. And let's consider the first divisor x plus 1. So if we consider that to be equal to 0, then x is equal to minus 1. So let's substitute. F of minus 1 into the equation is equal to 2 by minus 1 cubed, minus 3 by minus 1 squared, minus c by minus 1 plus d. And we know the remainder is 64. So 64 is equal to minus 2, minus 3, plus c plus d. Let's carry the numbers across. Minus 2 minus 3 is minus 5. When we carry it across, it will be 64 plus 5, which is 69, is equal to c plus d. And let's call that equation 1. And similarly, for the next linear factor that we're using as a divisor, for x minus 2, then we consider it to be equal to 0, so x is equal to 2. So we'll do that substitution. F of 2 is equal to 2 by 2 cubed, minus 3 by 2 squared, minus c by 2 plus d. So we substitute because we know the remainder is 64. So 64 is equal to 2 cubed is 8, 8 2s are 16, minus 2 2s are 4, by 3 is minus 12, minus 2c plus d. And 16 minus 12 is 4. When we carry it across, it will be 64 minus 4 is 60, is equal to minus 2c plus d. And we'll call that equation 2. If we put equation 1, 69 is equal to c plus d, and equation 2, 60 is equal to minus 2c plus d, and we subtract, that is going to give us 69 minus 60 is 9, is equal to c minus 2c, c plus 2c, which is 3c, and the d's cancel. As such, c is equal to 3. So we found one of the values, and if we want to find the other value, we can just substitute for c into any of the equations. So let's use equation 1. 69 is equal to c plus d. So 69 is equal to 3 plus d. Carry the 3 across. As such, 66 is d. Part B, show that the expression root 25 over root 45 is the same as root 5 over 3. So we're required to prove that. And this falls under the topic of Surds, Indices and Logarithms. So let's look at the left-hand side, the root 25 over root 45. And what we can do, we can separate it. Root 25 is root 5 by root 5 over square root of 5 by root 9. And the square roots cancel, the root 5s cancel. So we're left with root 5 over root 9. And the square root of 9 is 3. So this is the right-hand side. So we can bring up a small rectangle or write QED, quad erat demonstrum, which shows that we've proven what was required. May 2022, number 2C, part 1. Given that the function g of x is equal to a quadratic, 6x squared plus 12x minus 18, express g of x in the form a x plus h all squared plus k. So this here looks at completing the square, and completing the square falls under the topic of quadratics. So we've already done questions in May 2018, 2019 and 2021 with the 3 types, one being using expansion, second one we use the quadratic formula, and the third one we use algebra tiles. Any one of the methods will work, so in here we'll use the formula. So let's rewrite the quadratic. G of x is equal to 6x squared plus 12x minus 18, where the coefficient of x squared is a is equal to 6, b is equal to 12, and c is equal to minus 18. So we want to find 6x squared plus 12x minus 18, and we write it in the form a x plus h all squared plus k. We already know a is 6, and we want to find the others. So from the quadratic formula, if we highlight b over 2a, that will give us h. So we can substitute from there. H is equal to, what is b? 12, we have that in green, over 2 times 6, which we have in red. So 12 over 12 is 1, so h is equal to 1. And for k, if we look at what is inside the square root sign, b squared minus 4ac, and we flip it, we're going to get k is equal to 4ac minus b squared, all over 4a. And if we substitute 4 times 6, which we have in red, times minus 18 minus 12 squared, all over 4 times 6, and that works out to be minus 24. So 6x squared plus 12x minus 18 is equal to 6 by x plus 1 all squared minus 24. Part 2. Using the expression derived in C part 1, determine the roots of g of x. In order to determine the roots, we need to make the equation equal to 0. So let's rewrite it. 6x plus 1 all squared minus 24 is equal to 0. And let's make x the subject of the formula. That will give us our roots. So let's carry the minus 24 across. We're going to get 6 by x plus 1 all squared is equal to 24. And if we carry the 6 across, which is multiplying on the left-hand side, then we'll have x plus 1 all squared is equal to 24 divided by 6. So x plus 1 all squared is equal to 4. And we can now get rid of the square sign on the left-hand side. So it becomes square root. So x plus 1 is equal to square root of 4. So x plus 1 is equal to plus or minus 2. And in that case, x is equal to minus 1 plus or minus 2. Either x is equal to minus 1 plus 2, meaning that x is equal to 1, or x is equal to minus 1 minus 2. So x is equal to minus 3. Hence, sketch a graph of the function g of x. And we know a couple things. We know the roots are at 1 and minus 3. That's where they're cutting the y-axis. And we know if you look at the original equation in part 1, a is equal to 6, meaning it's positive. So it's a U-shaped graph having a minimum value. And we know it is cutting at minus 18. Since quadratic equations are symmetrical, it means that halfway or in the middle of the two roots, minus 3 and 1, will be where the line of symmetry is, or the axis of symmetry, or the mirror line. So that means that the minimum point occurs there. So, and the midpoint between minus 3 and 1 is minus 1. We've now come to the end of CSEC past paper questions in Algebra, Sequences and Series, which is the first of 4 sections in Additional Mathematics. In our first video in this playlist, we looked at past paper questions from 2012 until 2016. And in this video, we looked at from 2017 until 2022. Don't forget to look at the description down below. We've outlined the 4 sections of the entire Add Maths syllabus and the order we suggest that you go through it, a better grasp of the subject area.